Alright, so in the beginning there was a cylinder. Okay. And this cylinder wanted to be a hinge. So let's make it a hinge. Let's start out very basic hinge. See, this lesson entails you actually flattening out an object. In other words, you can't print this unless you split it. And that's the idea here. We must have something that we can split to understand that concept. Okay, so I have this. And let's think about the sturdiness of it. So we'll make it like 20 by 10 by 10. And I'm just grabbing a pair of calipers right here to see how thick that is. So 20, yeah, that works. And 10, yep, that works also. Okay. My American mind wrapping myself around metrics. I'm loving it. Okay, so here we're going to make another cylinder. We're going to put this inside this one. And in order for that to happen, we would have to gauge this one as the scale of 10. So this one would also have to be what? 10. Good. And how far this goes out, well, who knows? So let's take this and duplicate it. And what I'm going to do is make a cube for sizing purposes. And if I want a loose joint, what I want to do is set down a dimension that the two forms meet. Now it could be 1 millimeter, that's a pretty loose joint, or 0.5 would be a tighter fit joint, but nothing below 0.5. And I would argue 0.8 is a safe method to go. Okay, so pretty simple already, right? 15. Duplicate this one over. Duplicate this one. Okay, so what happens here in the back? Well, we could use this cube. Let's use it. We'll end up making another cube to size things up, but who cares? Now, the distance between these two objects, what is that? I mean, I could try to eyeball it, but I could duplicate these and object join them, and it would give me my x dimension, which is now object transform origin to geometry. So this is 20. No, 31. Object apply rotation and scale, and what that will do is set back the original x value. So it zeroes it out and allows the rotation to become true. So this x rotation is a true. If you notice that when I undo that, the z rotation is the 31, but that's not true because look at, I'm looking at it in x. So that x value needs to be changed, and that is apply rotation and scale allows you to do that. Now its true rotation and its true orientation is 31 in x. Okay, cool. So I could take this and copy it. and paste it here. There we go. What I want to do is set that to about 0.8 there also. And I could, if I want to be safe and if I need kind of spacing, I can do that too. Just like that. And how thick do I want this? Well, it doesn't have to be too thick. We're going to make a thing that interacts with itself and is modular. What's its purpose? You know, every student always says it has to have a. What does it do? It teaches you. It teaches you. That's its purpose. Students of this age they are interesting beings. There's no doubt about it. So it's 20. Alright, so there we go. Now we just have to make it into a joint. Well, if I took these objects right here and joined them, and let's get rid of this one so it's not so confusing. All I have here is two cylinders, a cylinder, a cylinder, and a cube, right? So I have to take these cylinders and push them back into the cube, just like this. And there we have this. So we need to make these two forms like that. So we need to Boolean them. So my first object is cube 0, 1. This one's cube or cylinder 0, 3. Wow. So for this one, I will take and Boolean a union and then cube 0, 1 and apply it. And now I could get rid of this one. I'll put it down here for right now. So there we go. We got two forms that are touching and good to go. So now what I want to do is duplicate this. Shift D to duplicate it and then go back here. And then put this right about here. Because now we need to state how thick we want this. So you see, once you print one, let's say I print 3 of these and 3 of these, I can put them together and make one object that is just a constant hinge. Now, for this to work, however, this works right here. We can join those two together too. So let's join those two. Cylinder, cylinder. No, what is that? Cylinder, cylinder 1. So original cylinder. There we go. Move that piece, and now we got those two forms. This one, the diameter of it needs to change. Okay, so right now its diameter is 10. Well, what it would have to be was 10.5 in diameter. Slightly bigger than the original. And then I can use it to cut into this form. That one is cylinder 2. And there we go. So essentially this is what I have now. I have two forms. Shift D, and if I was to print another one, it'd go something like this. And Shift D would go like this. And I can do that on and on and on and on until finally it just keeps wrapping all the way around to make some kind of bracelet or something. Pretty neat, right? So let's print this bad boy out. Let's just print one of them, or at least two, so that we can know that they interact with each other. And how do we do that? Because there is no flat surface on any one of these objects. If you look at them, okay, there's no flat surface. Certainly maybe this one I could print straight up, but this one is round here and round here. So now we have to learn how to cut a model in half. And once we learn that, it's all downhill after that. It's because you can make just about anything, because it doesn't matter if you have rounds on other sides. So in the next video I'll show you how to cut a model. Okay, so before we cut, one thing we have to do is we have to have something in order to pivot on. So here, for example, the smallest filament we have is 1.8. And really, for this hole right here, because I don't want to drill it, I use 2.5 and sometimes 2.8. I know that goes outside the law of 0.5, but there's no law. You just got to go with it. Now I need to know the exact center of this circle. How do I do that now, right? How do I do that? Well, I could do this. Object, apply origin to geometry. Okay, that gives me the center of the object going this way. And it looks like I'm dead on, because this was my original object. Now, if I had problems trying to find that center, sometimes I do this. Remember, Blender is not a CAD program. So you have to that's what the beauty of it is, though, because you have to think. So I can find the diameter by going like that. By making one of these as round as that and then finding the center to it. That's another way to do it. But in this case, the 3D cursor went right there. There's 2.5. So I need to cut this. This is called cylinder. So what I need to do is Boolean difference cylinder and apply it. That cuts through that one. Then I need to do it to this one. Boolean difference cylinder. Apply. So essentially, I now have a hole that goes all the way down the object. Perfect. Alright, now we have to cut it. Let's go to the next video.